Assalamu alaikum. My name is Mobin Malik, and this is actually the first lab of the microcontrollers and the embedded systems course. And in this lab, I'll basically go through how to set up this Atmel Studio and how to write the assembly language and CAVR codes into this software, and how to upload the code or the hex file onto your microcontroller. So starting with how to create this file, this is how you go. You go to File, New, and you go to Project. This is in the debugging mode, so I'll stop it, and File, New, Project. And after going into the project, you select what type of the code you're going to write. And this is the C++ code, this is the assembler code, and this is the Microchip Studio solution which we are going to use. And after going into the type of code you're going to write, suppose if I'm going to write this AVR assembler code, I'm going to double click here, and when I double click on the AVR assembler, this is where it asks what microcontroller I have. So I have an ATmega 2560 or Arduino Mega, which by the name it is commonly known. So I write 2560, and here is the name of the chip. You just double click and the file opens in front of you. So let's get back to where I was. I'll open my file which I've already created. Atmel Studio 7.1 assembler application, and this was the project I had opened before, and I have the simpler blinking code already written into it. So this is an assembly language code. It is a well commented code, and I'll explain it to you a little bit. So what you do is, this is basically a line that actually tells you what is the next instruction that is going to be written. This is a jump command that is used to jump into this main label, and after jumping into the main label, this LDA command loads the register R16 with value 0xFF, or this is actually 255. Out DDRB R16 means that the DDRB, that means that the direction register of port B is set with the value that is already included in the register R16. So after this is done, this is a loop. In the loop, this command set bit input port B5. Port B is the actual port of the microcontroller that I'm going to use, and the 5 is the bit number which I'm going to set. SBI command sets the bit and CBI command clears the bit. R call is basically a calling operator that calls this specific label delay underscore 05. This is the label where I have used some useless commands just to create a delay, and this type of delay is created by wasting some CPU cycles. So this delay is called, and after this specific delay is called, we turn the bit 5 of the port B off, and the loop goes on and on again. So now I will show you what this code looks like in the simulation. So this is basically my Proteus window, and this is my microcontroller in which I'm going to upload the code. So to upload the code, you have to right click on it. When you right click on it, this program file label, you have to click on this open file button, and you have to locate where your hex file is. Now to create the hex file, I'll again open this window. You have to press this debug button. This debug button is what enables you to run the program and creates a hex file, which is then uploaded into your actual microcontroller and in the simulation too. So after creating the hex file, you have to just double click it or open it, like I'll do right here. And if I then select OK and run the simulation. This is the LED that is connected to the bit number 5 of port B. So the program, what it does actually was it created a delay. So this is the delay that this LED blinking is what actually was our lab 1, and this delay is created using the assembly language. Now we will have to write the same code in C language. So we'll go File, New, and I'll go to the project and C++, and I'll have to select GCC C executable project because I'm going to write my code in the C language, and I'm going to name my my file as 191.003 blinking lab 1. Okay, and now I have to select my microcontroller, which will be selected after this window. This project is creating, and I'll go for 2560, and this is my microcontroller. After selecting the microcontroller, I already have my code copied, so I'll just paste it right here. I'll have my name 191.003. I'll have to comment it. So how this code is actually working: you have to first define the frequency of your CPU, and by CPU I mean your microcontroller. So the microcontroller I have has an output also and has an oscillator that has a frequency of 16 megahertz. So this is the value that I've set. This is a library that you have to use in order to define the inputs and outputs and registers and ports and everything that is related to your microcontroller. So after that, you have to include a library for the delay. Hashtag include util delay. This is the library that you have to use that enables you to use this this command, that is underroot delay underscore ms1000. 1000 basically means a delay of 1 millisecond, and a 1 millisecond delay actually means a 1 second delay. So if I change, let's show you the code first. ddrb1, this command, this operator basically enables you to set the 5th bit of port B as high. And by high, I mean that this bit is now set as an output. So after setting this bit as an output, I now can use this loop to show any of the command I would like. So if I say that the port B, the 5th bit of port B gets high, stays on for 1000 milliseconds, and then turns off and stays off for 1000 milliseconds. So this will create a blinking code that will be on and off for 1 second only. So to change, let's suppose I'm giving this a 200 value. So that means it will be on for 200 milliseconds only and will be off for about a second. And now I have to select the simulator, and I'll have to start the debugging process. It takes a little bit of time for the first time, and once the debugging is done, you open your software and double click your microcontroller, go back to where your file was created. This is actually my file 191.003 blinking lab 1. Double click again, debug, and this is where my hex file is stored. I double click on my hex file, click OK, and now the program is actually loaded into my microcontroller. So when I press the start button, this is the LED you have to monitor. It stays on for about 200 milliseconds and then stays off for about a second. Let's shift the functionality to help you explain a little bit. I want it to stay on for about 2 seconds and be off for only about 500 milliseconds or about half a second. I'll debug the program again And after that, I'll go here and start my program again. Now this LED is on for about 2 seconds and then off for about half a second. So this was basically the introduction of what the lab 1 is all about. And this is the video in which our hardware is working.